My name is Mike Adcock. I'm a principal at RWB Consulting Engineers. I started with RWB in 1996, and over that period of time I've worked on many different sectors of buildings, such as commercial office buildings, aviation facilities, flight training facilities, and then into the mission-critical design. Today, RWB is recognized as one of the experts in the crypto mining and data center facilities. In 2018, we started our first crypto mining facility. Since then, we've designed about 3.1 gigawatts of crypto mining facilities with many different clients. Some of those clients include Core Scientific and Applied Digital and Ionic Digital. Now, our clients are looking at us working on the HPC, or high performance computing data centers, as well as AI data centers. The role of an MEP engineer on a data center project is to work with the owner to provide a sustainable, energy efficient data center facility that operates without interruption. The data center market has had a big impact on how RWB does projects. Instead of being on an architectural team and doing designs simultaneously, a lot of the clients now come to us directly at the beginning of the project because the MEP is such a big part of a data center or a crypto mining facility that they want to get us on board early. At that time, we're looking at locations for the facility and potential sites to develop. The MEP systems are such a large part of the cost and the delivery schedule of a data center project. Most owners want us to come on board so that we can work with procurement specialists to help secure and make sure that the proper equipment has been purchased and arrives on time at the site so that it does not have an impact to the construction schedule. Speed to market is one of the first things that an owner talks to us about when they bring us onto a project. They want to know how quickly we can get the design done. They want to know when the equipment can be selected and procured so that it can be on site when it's needed for the construction schedule. We have relationships with many different types of engineering specialists and even procurement specialists, people like that can help us improve the delivery time of an operational facility to an owner. As an MEP engineer, some of the key things that we have to design for include power to the facility, heat rejection from the facility, and then also the energy efficiency of the facility. Meeting the power requirements for a data center facility is extremely difficult. We have to find locations that have sufficient power or a substation nearby, and in the future we know that we're going to be using microgrids to power some of these data centers because demand has increased so much and it's beyond what the grid can provide. As far as heat rejection, there are several different methods that are being used for that now. It depends on whether you're doing a crypto mining facility or an HPC data center or even an AI data center. The density of the equipment and the heat rejection rates are extremely high. Some of the different types of methods that are used for that are the air-cooled systems, and then there are water-cooled systems. Immersion cooling has been looked at a little bit, but now it seems like the focus is completely on the direct-to-chip and liquid cooling. Most of the data centers that we've been working on are located in remote areas, such as West Texas, where there's not any city water, there's not a source for water. So they're required to drill wells, and even that there's such a demand on the amount of water that's needed for these large data centers that it's just not practical. In those situations, we've now been using air-cooled equipment, air-cooled chillers or dry coolers, and that type of system is being used frequently to be able to reject the heat and maintain the cooling requirements for the data centers and the crypto mining facilities. Many of our clients are trying to find ways to support their data centers without the normal power connections to the grid. We've had some situations where clients have come to us and they want to use flare gas from the oil field to power generators, and then those generators would then generate the electricity to power the data centers. Many of our clients are finding atypical ways of powering their data centers. The need is to stay off the grid, or even to provide something that's more reliable than what the power grid can provide. And again, that's why we're looking to microgrids in the future to power each of these data centers individually.